Spectrum analyzers are powerful pieces of test equipment that can help to troubleshoot, characterize, and fix RF-related issues. Instruments equipped with a tracking generator also have the added benefit of being used as a scalar network analyzer. This feature can be used to test characteristics of circuits such as system gain, frequency response, and return loss. The following demonstration is an introduction to testing a filter using a spectrum analyzer with a tracking generator. For this example, we are going to take a look at a 300 MHz bandwidth low-pass filter. A tracking generator is a signal source which has its output frequency locked to the spectrum analyzer internal local frequency. As the analyzer sweeps from the set start frequency to the set stop frequency, the generator output is sourcing at the same frequency values. It tracks the input sweep. As the picture shows, the tracking generator outputs a signal at the same frequency configured for the sweep. The sweep signal output by the tracking generator can then be routed through the device under test and back into the spectrum analyzer. And this allows you to visualize the frequency response curve of the device under test. In a real testing situation, we need to adjust the start and end frequency according to the test region for the filter we want to test. Note, choosing a small RBW or resolution bandwidth can help reduce the DANL to get better amplitude accuracy. Now let's take a look at the detailed measurement methods. First, connect the tracking generator output to the RF signal input through any cables and adapters that we'll be using to connect to the device under test. Turn on the tracking generator and set the TG output level that is appropriate for your device. Enable normalization to compensate the system frequency response between the tracking generator and connectors and adapters that we may be using. Adjust the tracking generator reference level location to observe the measurement and results easily. Note, the tracking generator reference level only changes the location of the signal displayed. It does not change the spectrum analyzer reference level. To observe easily, we can set the activity function area to a suitable location. Connect the filter to the system and observe. The spectral scan line displayed is the filter frequency response curve. To test the 3 dB bandwidth of the filter, turn on the delta pair marker, set reference marker to the left of the screen, set the delta marker to the location differing by 3 dB with the reference marker, and now the frequency of the delta marker is at the 3 dB bandwidth of the filter. You can use the amplitude menu to adjust the vertical scale and view the full performance of this filter. As you can see, the flatness deviation is about 1 dB, with an insertion loss of 0.5 dB. That concludes the introduction of using a Rigol spectrum analyzer with tracking generator function to test the frequency response of a filter. Here are some notes. First, connect the tracking generator output, cables, and any adapters to the RF input. Perform a normalization. Connect the filter. Use the marker function to test the response of the filter. Thank you.